Okay, so this is fourth period. Questions for the review? Yes. Okay, give protons, electrons, and neutrons. Okay, so let's pick one of them. That's this one?
Yeah.
Okay. So this is the ion she's asking about, how to tell how many of each one I have. Okay, usually it will have a number. If it doesn't have a number on the bottom number would be the number on the periodic table. Oftentimes they don't write it because you can just look and find it yourself. If we looked and found it ourselves, it would be 12. So it would be written this for a full nuclear symbol. That number that it is on the periodic table is the number of protons. So that always is the number of protons. The number of neutrons is just take the mass number, which is the top number, subtract the protons, and you've got the neutrons. So here it just happens to be the same. It is not always the same. It's important to know. Okay? And then the electrons, these things change if I have a charge. So if I don't have a charge, the protons and the electrons are the same. If I have a charge, then the electrons change so that I get the charge. Since I have a positive 2 here, that means I have 2 less electrons than I do protons. Okay? So 2 less electrons would make it 10. Okay? All right. Any other questions on any of the worksheets? Colligative properties, the molarity, molality, anything? Yes? Okay, you got them all done? Yes, sir. Okay, colligative properties worksheet. Okay, anytime I go from just a plain solvent to a solution where I've added a solute, I get my 4 colligative properties. Do you guys remember what the 4 colligative properties are? Boiling point, elevation, freezing point, depression, osmotic pressure, so osmosis is possible. Something else goes down. Vapor pressure lowering. So there are 4. So anytime I add a solute to a solvent, those 4 things happen to that solution. So the freezing point goes down. The boiling point goes up. The vapor pressure goes down. And osmotic pressure can happen. Okay? So that was questions 3 and 4 on that colligative properties, right? So I'm adding a solute to a solvent, making a solution. What happens to the boiling point? Goes up. What happens to the freezing point? Goes down. Why does that happen? Because I added a solute to a solvent, made a solution. Now I have 4 colligative properties that address that solution.
So when it talks about sugar,
doesn't matter what it is.
It'll be higher.
It'll be higher. Yep. Okay, what's the equation that we're using with colligative properties? And then I, right? And then all I have to do is for freezing point, I would put FP and I'd put KF. For boiling point, I put BP here and I put a small b underneath where the K is. I just plug in. Okay, well, what does each of those mean? Well, delta T, change in temperature, right? K, constant for either freezing or boiling. M here is what? Molality, moles of solute divided by kilograms of solvent. And then I is how many parts does it break into, or how many ions does it break into? If it's covalent, it's always just one. Not going to break it. Like the sand we talked about. Okay, sand doesn't break up. Okay, any specific questions on here you'd like to go over? Number 2 is just like number 1. Yep, and you got to explain each of them just like I did. K's are the constant for either freezing or boiling for that substance. Okay. Any other questions? Molarity questions, the lab questions, colligative property, how to put it through. Yes, Dallin. I is how many parts it goes through? Okay, molarity practice number 2, problem number 12. What does it say? C3H8O. Okay. All right, so molarity, if you remember right, is moles divided by liters, right? They're wanting us to find liters, so we're going to take moles and divide it by molarity. First we have to have moles. We don't have moles. How do I find moles? Well, I have to add up 3 carbons, 8 hydrogens, and an oxygen. Once I've got that added up, I'm going to take this and divide it by that, and that's my mole. And then on the bottom, molarity, 3.4, plug through. Okay, so this is a divide sign right here. So that means divide by whatever I got here. So 78 divided by whatever I got here. That answer is going to go here because that's my number of moles. Okay, so that's the molarity practice number 2, number 12. Okay, any others that you'd like to go over? Yes. Okay, colligative properties, number 6. Okay, read what it says.
What is the change in freezing point versus pure water? 0.78 molality solution of NaCl in water. And it gives you the Kf is 1.86 and assume the I is.
And we could have figured the I is 2 because this will break into Na plus, Cl minus. That means there's 1 plus 1, which is 2 particles. Yes. I just, how many parts will it break into? So if it's ionic, how many ions do I have? If it's covalent, it's always 1. If it's something like C6H6, or like we had on the other one, C3H8O, that's not going to break apart. We don't know specific ions. Okay? All right, so here we're going to do the same equation. Delta TF equals Kf times molality times I. Well, we've got everything. We just plug in. Oops. 1.86 degrees Celsius per molal times 0.78 molal times 2. Molals cancel. We end up with degrees Celsius. And that would be the change. If I wanted to find out the actual temperature, I'd take 0 minus whatever this was. And it would be a negative something degrees Celsius would be the actual new freezing point.
Once you do that, you could use 0 minus.
Mm-hmm.
Or you could get rid of it.
So that was number 6. Now, if you're doing boiling point and it's water, what does boiling point normally boil at? 100 degrees. So once you get the delta T for boiling point, you have to add it because we were boiling point elevated to 100 to get the new boiling point.
So if I did the 1.86 times 0.7 times 2, and it came out to 2.9, it would just be negative.
Yep. Okay. Anything else? This is your chance, guys. Get help. Number 7. Same one. Okay, go ahead and read it.
By dissolving 0.42 moles hexane, 500 grams of CCl4. And what is the change in freezing point versus pure CCl4? Kf for CCl4 is 30.0 degrees Celsius.
Molal. Okay, hexane, you don't need to know it, but that's what it is. Okay, so it's a big long molecule. Not as big as octane, which you burn in your car. So here we've got everything we need except for mol-al. So if we look at the equation, delta T Fp is equal to Kf times mol-al times I. We don't have mol-al. So if we remember, mol-al is equal to moles divided by kilograms, then we can quickly get it by saying, oh, we've got 0.42 mole. And if I divide that by 1,000, 0.5 kilograms, right? 0.5 kilograms. Then I've got mol-al. Then it's just a matter of plugging in. Now, they want to change. If they say change, then you leave it. But if they want the new freezing point, then you got 0 minus that. It'll be a negative. Yep. It's a kilogram. Sorry. Okay, any others that you'd like to go over? Yes, sir. Nope. Any other questions? Now, this one would be not 0 minus something because this is actually carbon tetrachloride, which is a carcinogen that they used to use a lot to dissolve organics in, but then they found it was a very high carcinogen. So it's 0, its melting point or freezing point is not 0, it's a different. So I'd have to go the new temperature or its normal freezing point temperature minus the change in freezing point to get its new freezing point. The 0 just works for water, and the 100 just works for water. Okay, does that make sense? Okay, we've got any other questions that we want to go over? I'm giving you guys an opening here. Any other worksheet you want to go over? Anything? Everybody understands what we're doing for lab? Yes? Number 13, molarity, number 2. Okay, go ahead and read it. Volume of 3.3 liters and what? Okay, ammonium is NH4 with a +1 charge and what? Sulfite, SO3 with a -2 charge, so I need 2 of those. And then I would erase, my eraser's not high enough. Oh, hello, we don't want to do that. Erase that top part. Okay, SO3. All right, so the first thing I need to do to get concentration, it asks concentration in what? We're working on a molarity worksheet, so it's probably molarity. Molarity equals moles divided by liters. So I got to get that into moles. So nitrogen, 2 of them. I had one of those moments, just a second, sorry. And hydrogen, 8 of them. Sulfur, 1 of them. And oxygen, 3 of them. So we'll add that all up. Once you've got that all added up, you take 12 grams divided by 1 mole, and you take these grams right here, and they would go here. That would give you moles. Once you've got moles, you take your moles divided by your 3.3 liters, and you have your concentration in molarity. Okay? Yeah.
Number 9, it asks a solution of propylene glycol in your car's radiator freezing point from -20 degrees. What is the molality? And the water is 1.6.
Okay, so it wants to find the molality. What number was this? This is colligative properties number 9. Okay, so if we look back at the equation, delta T for freezing point is equal to K of freezing point times molality times I. If I'm solving for molality, molality is going to equal the change in temperature of the freezing point divided by Kf times I. Well, if my new freezing point is negative 20, then my delta Tf, or delta T freezing point is 20 degrees. It changed by 20 degrees, right? So now we just plug in everything we got. And we get the answer. Because we have Tf, that's right here. We have Kf, it's right here. And we have I, which is right here. Okay? Any other questions? FP, that was an F. Sorry.
What is molality? Like, what do you put after? So okay, 10.7.
It would just be that little cursive M. Molality is just moles over kilograms. Moles of solute over kilograms of solvent. Okay, any others? We okay? Okay.
Let's do. How many moles of salt would you need to add to 1 kilogram of water to make the water boil at 100?
How many moles?
Yeah.
Tell me the rest.
1 kilogram of water boil at 105 degrees Celsius. Kb is 0.25 and I is
0.25. And this is Kb.
Yeah.
Is there anything I need? I is 2. This is a salt. Okay, so what's my delta Tb? What? No? 5. Okay, my original temperature was 100. Now I've moved up 5, so my Tb is 5 degrees. So it wants to find moles. I'm going to find molal because that's for easiest first. So I've got the equation delta Tb equals Kb times molality times I. So I'm just going to solve it for molality. Molality is delta Tb P divided by Kb times I. Plugging in, you got 5 divided by 0.25 times 2, and we get 10, right? Or 10, or about 11, somewhere in there. Is that right? Yes. Because they said he was making something, spaghetti, so he's probably putting that salt in water. I don't know another thing that a chef would do. Besides, it says, oh, it said to water right there. So water boils usually at 100 degrees. The normal boiling point. Normal boiling point means 1 atmosphere, 25 degrees Celsius, well, 1 atmosphere going across. Okay, so it's between 10 and 11, if I'm right, if I remember. Is it 10? Okay, so that's molal. Okay, and it wants to find moles. Well, if I remember right, this is moles per kilogram, right, for molal? Yeah? So you times it by 1 kilogram, and that tells you how many moles. And the last one is just changing those moles to grams. So it's salt, NaCl. Add up the mass of salt, times it by the number of moles, you got your answer. 10 moles, yep. Okay, we're going to move on, if that's okay. If you have more questions, I'll be here after school. I'll be here tomorrow before and after school, hopefully, no problems. And then your test is Friday. So if you're not understanding this, you need to get in and get some help, okay? All right. So what we're going to do now is we're going to go back and talk about your lab. Now, I broke you into teams, and you were supposed to do some research and do some finding some stuff. We're going to have this up on the board, and I'm going to have your team put information in. You should have been able to find every column except for freezing point right now. okay? Except for freezing point, which is solution FP. That's what we're going to do in lab today. So, review really quickly of what you need to do. When you go back into lab, you must have goggles on, okay? Because we're working with chemicals today. We're not working with glass, so you don't need aprons on unless you want them, okay? When you get back there, you've got a styrofoam. You're going to want to look, first of all, for your chemical, because they're at different places all over. Go be with your chemical. Grab a styrofoam cup, put it on a scale. Weigh it. Write it down. Add about 200 grams of ice. Write it down. Now here's where it gets tricky. Most of these scales won't weigh more than 250. So you need to add just water until you're just barely below 250. Otherwise it won't weigh them. Okay, so I know I said 100 grams of water, but we don't have scales that will weigh 300. Okay, so you're going to have to be a little tricky here. Take it up to as close to 250 as you can. Okay? Then you're going to get your calculator with your temperature probe, and you're going to stir that temperature probe until you get the lowest temperature possible. What should it be about? Just with the ice and the water. About 0, right? We're hoping for close to 0. So you're going to get as close to 0 as you can. That number is what goes up on the top right here. Okay? That number goes up there. Then you're going to take the little teeny plastic 50 milliliter beakers that are back there, put them on the scale, zero it out. Add 2 grams of your salt. If you don't get it exact, write down exactly what you did weigh out. Okay? Some of them are hard to weigh out because they come in crystals. So get what you weighed out. You're going to take that, you're going to put it into your ice water mix, and you're going to stir till you get the lowest temperature you can get. It'll probably take you about 5 minutes to get all that salt to dissolve and get to the lowest temperature you can. Write that down. Once you get all that done, then you can clean up. Dry your temperature probes, dump out your solution, rinse it out. Don't throw my styrofoam cups away because they're not environmentally friendly, and we use them as long as we can until they don't work anymore. Okay, but rinse them out really good. Go to me for a stamp. I'll stamp it. Go wash your hands. Come back into the class. At the back is where you go through, and it just tells you exactly how to make the ice cream. Make your ice cream, put it into a bucket back there. It's going to be in plastic bags. Put it in a bucket, bring it to your area, and sort of shake, shake, shake. It takes about 10 to 15 minutes to make your ice cream. In the meantime, finish your lab, and it doesn't have to be shook constantly. You can I put it down by my feet and sort of bump it every once in a while. It works. Okay? After about 10 to 15 minutes, push the ice cream in the baggie like this. Okay, so squeeze it. If you squeeze it, then let go and it stays squeezed, ice cream's ready to go. So then you go back to the back and you take the temperature probe I've got back at the back and you put it in there and you get the temperature of the ice water mixture, not the temperature of the ice cream. That would be gross. Okay, just the temperature of the ice water mixture. That goes on the back. Then you got to figure out from that what the molality of the salt is. Okay? After you get to that point, you're going to go and you're going to dump out the water in the sink. Do not dump the salt in the sink. So if you turn it sideways so the baggie, all the salt falls into the corner of a baggie, then you can grab that and use it and dump it out. Grab your small bags as they go to fall out, because that's your ice cream. Re-ziplock the big bag, throw it away. Take your little bags, take the ice cream out of the littlest bag, and you can put it into a cup, get a spoon, and you can eat it. Okay? It's all written back there on the back. If you forgot any of it, it's back there on the back. Big, deep sigh. Okay. So back to the thing. Styrofoam cup, weigh the styrofoam cup. 200 grams of ice, weigh it. Up to that 250. Don't go over 250. Get really close, like 249. Don't go over 250, adding water. Okay? Questions? Okay, I'm going to refill the ice, and I'll be right back there with you. Okay? Let's go. Any other things that need to be put up? Get them put up. You can take a picture of it with your phone if you want to, but it will be up on the blog. I'll put it up on the blog for today. It'll be at the end of the video for today. That's what I'm recording right now. Okay, but you can take a picture with your phone just to make sure that you don't lose it. Everybody got it? Last call, last call. Okay.
Wait, so we're not